Bismillahirrahmanirrahim. Assalamu alaikum. So let's work with the greatest integer value function, and we will consider first its shifts. We will apply shifts to this f of x equal to greatest integer value function that we have defined in the previous videos. I'm sure you guys remember how the graph of this function looked like. So first we will consider its vertical shifts. In vertical shifts, first let's consider upward f of x equal to, when we add something to this, x plus something, let's say 4, this will shift this parent function 4 units up. And if we are subtracting something, let me use this color, let's say x minus 2, then this will shift this graph 2 units down. So let's do this. First of all, we will be plotting this f of x equal to greatest integer function or step function plus 4. That's my y-axis, this is my x-axis, and if you guys remember, then our parent function looked something like, let me first label this and then tell you how did it look like. So it looked like this. Okay, so let me this, don't consider this, something like this. It looked something like this. Now we have to shift 4 units to each of these, so when this page will be moved 4 units up, so this will go 1 2 3 4 here, 1 2 3 4 here at this place, and this page will also be moved 4 units, and this will be here. Similarly, this page will be moved 4 units up, this will be here. Similarly, this will be moved 4 units up, this page will also be moved 4 units up, and on the same lines this will be moved 4 units up, 1 2 3, that's 4 here, and you will continue the pattern. Okay, so like so this yellow colored graph is the 4 units upward shift of greatest integer function. Similarly, if you are talking about the graph of this function, g of x equal to this greatest integer x minus 2, then what all you need to do is you need to shift your greatest integer value function's graph 2 units to downward. Okay, so we know that we have one page here like this. If I shift this 2 units down, so it will be 1 2 here, so this page will be here, and we remember that we had a page of greatest integer function here, so this will be moved 2 units down, 1 2 here. Similarly, you can continue the pattern, so that's the 2 units downward shifted version of greatest integer function. This is how it will look like. That's the sketch. Y x x bar y bar, of course this is 1, this is 2, this is 3 4 5, so on. Yeah, you can do that. And similarly, if you are now talking about left and right shifts or horizontal shift, so when you will subtract something from the value of x inside this bracket, if you are adding something, so this will shift the greatest integer value function two units towards left. So we know that there is one page here of the greatest integer function. This will be moved 2 units towards left. So 1 2, so every point will be this page will be moved here at this place, and we have one page here from 1 to 2, and this will be moved here, and we have one page here, this will be moved here. Similarly, you can continue the pattern. So that's the okay, let me change this color. So this yellow version, this one is the graph of this function, which is 2 units shifted towards left to the original parent function. Now similarly, we can consider y equal to x minus 3. So what we will do, we will move 3 units towards the right to the integer greatest integer function. Let me first label 1 2 3 4 5 6 7 minus 1 minus 2, oh, minus 2 minus 3 minus 4 minus 5 minus 6 minus 7 minus 1 minus 2 minus 3 minus 4 minus 5 minus 6 minus 1 minus 2 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. So if I talk about the parent function, then the parent function looks like this. Something like this. So what we have to do, we have to shift this greatest integer function 3 units towards the right. Let's plot this with green. So this page, when I move this 3 units towards the right, then it will be 1 2 3 here. This point 0 0 will be moved to 1 2 3. So where will this move? Page will be moved here. Similarly, this will be moved here, and you can continue the pattern. We can just kind of check this on Desmos. So first let's plot the greatest integer function. This is the parent function. Now we will shift this function 3 units to the right. So you can see that this is how we were also drawing. Now you can ask the question, how will be the reflection? So reflection will just be how will be the reflection, like f of x equal to, if you consider this, then this is the reflection about x-axis, and g of x equal to x, this is reflection about y-axis. So when I will shift along x-axis, what will happen, and when I will shift along y-axis, what will happen? So let's take an idea first about this first one. So the part the page that was here will be shifted along with x-axis, so it won't go anywhere because we can't shift it along x-axis, so it will remain there. And the part of integer function which is here, we shifted 1 units here, and similarly this way. So there was, part of this parent function here, so this will be shifted 1 unit and it will come here. Reflected, I mean, not shifted, better word. This is, function 1. And what will happen in the case of this y equal to minus x? So you have parent functions, the page of parent function that is here will be reflected along y-axis, and it will be coming like this. And the page of a parent function which is here will be coming here. Similarly, you can continue the pattern. So that's how this function looks like. If you want to plot this, so first you need to reflect your parent function and then you take every page 5 units up. Similarly, if you want to plot this, okay, let's say minus x minus 2 plus 3, so first you need to reflect about x-axis, and then you take it 2 units to the right and 3 units up. If you are given with this minus x minus 3 or plus 3 plus 2, then first of all take this common. Now you start working. First you reflect about y-axis, then 3 units to the left and then 2 units up. That way you can plot.